Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So today's problem is the first problem about the particle hitting the surface. So we have the surface and we have the particle, and the particle approaches this surface with a speed v, and then it hits it and it flies with another speed. This is the initial speed and this is final speed. And of course in real life there is loss of energy and final speed is always a little bit less or significantly less than initial, but if there is elastic collision there is no loss of energy. And so what can we say? We can say that delta V, change of speed, is equal v final vector minus v initial vector. And of course we can deal with this. First let's deal with this with the coordinate system y and x, because it's always easier with vectors deal with it, and then I will do it the same with vectors directly. But basically if I have this angle alpha, then I can send along x v initial equals v final. There is no changes during elastic collision, and I assume it's elastic collision because nothing happens here. All the bounce happens in this direction. And so along x-axis initial equal final and delta v vector equals 0. So delta v has no component in this direction. And along y I can say that along y we have delta v, and this is vertical. It has final is v final cosine alpha, because it bounces under the same angle, or let's say cosine beta. Let's say it would be different. It cannot be different angle. I skip one thing. So along x-axis delta v equals 0, and that assumes that there is no energy loss. So we can say that delta v, I will not put delta vector here. I say delta, I will deal slowly, I will not jump. I will say that final is v, and let's say that v initial and v final are the same. There is no energy. The same in terms of length of the vectors. So v final cosine alpha, and let's call it beta, cosine beta minus v initial cosine alpha, and this is 0 because nothing changes in this direction. And v final, of course, equal v initial and equal v. So we will have v cosine beta equals v cosine alpha, and finally we have that beta equal alpha. And that's all I wanted to say. So I wanted to say that because this is, and let me wipe it out so make it clear, that because this is elastic collision, then the length of this vector is the same like the length of this vector. And I can say it because I will jump a little bit ahead, that energy before the collision is mvi squared kinetic energy, and energy after is mv final squared over 2. And those two are the same because there is no loss of energy. And that possibly means that v initial equal v final equal v. There is no other way around. If you put it here, you will have those things are the same. So this is, I assume that this is elastic collision, completely perfect elastic collision, and if so, the speeds are the same, nothing changes along this x, and that means that this angle equal the same. So angle at which it falls on the surface is the same that it's deflected. It's very often the case in physics. So in case of elasticity, it just follows the law of conservation of energy and the fact that there is no forces in this direction. So we know that those length of those two vectors is v. We did everything we could along the x-axis, now y-axis. And y-axis we can say the change of direction along this equals v final y minus v initial y. And this is delta vy, and it is v final from projection of this vector on vertical is v sine alpha. Because I look on this triangle, this is hypotenuse, this is alpha, this is v sine alpha. If you don't know this, please check my pre-request course, check my pre-request playlist where I solve all those trigonometry problems and vector problems. And v sine alpha is the projection of this vector. Projection minus, and projection of this vector is exactly the same from this triangle. It's exactly the same, only it's minus because this vector is directed downwards. So it's minus v sine alpha. And that means delta vy equals 2v sine alpha. And of course from x we already have it, but I will repeat it once again. Delta vx along this axis, v final x minus v initial x, and this would be exactly delta vx equal v final x is cosine alpha, v cosine alpha, v, this v from this triangle and this cosine alpha, and this is this projection, minus the same from this, but this time they are directed the same way, equals 0. So I have delta vy, I got it, and I'm starting from y-axis for whatever reason, and delta vx is 0. So my vector has this component 2v sine alpha and has 0 component. So vector is vertical and I know what length is. It length 2v sine alpha. It's how much the speed changes. And of course I can say that momentum is mv. So delta p equal m delta v. And I say that delta p, and this is delta p is this, and this is 2mv sine alpha. So what that means that I can actually draw the same line, I could draw the same line, the same picture, draw the same picture, and I could say that this is momentum, and this is another momentum, and this is initial momentum, and this is final momentum, and put the vector sign, and draw the surface, and draw the alpha, and repeat all of this, talking not about velocity, but about momentum. But whatever I do, I also want to come to this solution using vector subtraction. So, for example, if I deal with velocities, let's continue with velocities, I have to say that delta v vector is v final vector minus v initial vector. So this vector subtracts this. How I subtract the vectors? I have the first vector as this. This vector I have to reverse, and I have to put, or I draw this. So this vector I will repeat. This vector is v final, This vector I have to reverse because it's minus v initial, and then to add those two vectors, because this is exactly like writing v final minus plus minus v initial. Right? It just, again, go to pre-request playlist about vectors. And then I move this to the end of this. And I have this parallelogram, and I have this, and this is my delta v. This is the sum of this vector and minus vi. And this goes this way, and obviously if I draw this this line, it's rectangular triangle, this is v, this is v, of course this is alpha, this would be v sine alpha, and this would be v sine alpha, so of course delta v from this picture would be 2v sine alpha, which is exactly what it is here, this vector. So the bottom line, that when the particle hits the surface, and it hits the surface under the angle alpha, it creates change in the momentum. And change in the momentum is delta p, and this change over delta t, so that all happens during time t, it's equal the force. So the force that acts on the particle, the average force acts when this is hitting the surface. Let's not tilt it. I'm running a little bit ahead of me. When the particle hits the surface, from that side this time, and then it's rejected, and this alpha, momentum changes. What changes this momentum? The vertical force. So there is a force, same direction as this delta p, and this force, delta f, and this force is this, and they are connected like this. So I can say that delta p equal f delta t. This is called impulse too, but let's not overcomplicate it. What we know is that if we know delta p, and this is this, we know force. And this force equals 2mv sine alpha divided over delta t. And that's all we need, it's our first step. And then we say that third law of motion means that there is a force that acts on this surface. And this force is exactly the same, and it is described by this formula. So when the particle, and pretty soon I will say molecule of air, hits the wing, because this would be the wing pretty soon in my next program, in my next video we'll talk about this, it creates the force on the surface, and surface is the wing. So wing rejects the particle, that requires force, the particle acts back with the same force, and this is a force that acts on the surface from one particle. And that's all I wanted to say in this video, so subscribe, like, bell, ask your question about this if you don't understand, and I see you next time soon. Thank you.